Let's begin. Linear programming problems, the simplex method. So the type of problem, a standard form of a maximization problem that you have to deal with has this form. So f is equal, this is example 1, 3x1 plus 5x2 plus 2x3, and you're supposed to maximize this, and you're given some constraints. 2x1 minus x2 plus 3x3 less than or equal to 6. You have x1 plus 2x2 plus 4x3 that is less than or equal to 8. And the variables x1, x2, and x3, all of them are greater than or equal to 0. So they cannot be negative. So this is the typical form of a problem that you can use using the simplex method. So there are a few things that I want you to notice here. What makes this the standard form? This is the standard form if you have a linear combination of the variables equals some value that you want to maximize. So you're trying to maximize f. And this is given in the form of an equation. It's called the objective equation or the objective function. And it's always in the form of an equation in some variables x1, x2, x3, x4, so on. These values x1, x2, x3, all of them are non-negative variables. That means they cannot have negative values. They can only have positive values or zeros. So that's another thing that makes this a standard form. And then the inequalities that are given, in this case, you're given two inequalities. They always have the form less than or equal to. They don't have the form less than or greater than or equal to or greater than. They always have the form less than or equal to a positive number. So you see 6 is positive, 8 is also positive. If you had, for example, minus 6 here, this wouldn't be in a standard form. Yes. So there are three things that makes this problem a standard form. So the first one is that you have your variables, all of them are non-negative. The second thing is that the inequalities given, they have the form less than or equal to. And the third thing is that the constant that you have after less than or equal to is a positive number. So if any of these three conditions are not met, then the problem will not be in a standard form. You don't need to worry about whether the problem is in a standard form or not for the final exam. So I can give you an example of the final exam for fall 2019. You can see you're supposed to maximize P. So it's a maximization problem. Then x1, x2, and x3, all of them are greater or equal to 0. The inequalities, all of them are less than or equal to. And then after that less than or equal to sign, you have a positive number. Yes. So I can actually say there are 4 conditions. It has to be maximized. Variables have to be greater than or equal to 0. Inequalities need to be, all of them need to be less than or equal to. So you need to see this sign. And then after that, you should have a positive number. So if all these conditions are met, you're dealing with a standard simplex problem, which you can solve using the method I'm gonna present to you right now. Any questions so far? Yes.
Can you just remind me what maximize means, please?
Maximize means find the maximum value.
Okay, thanks.
Yeah. So you're trying to find the maximum value that P can attain given these conditions. Make sense?
Yeah.
Okay. Any other questions? Good. So now let's see what do we do as the first step. The first step that we need to take is to create something called the Simplex Tableau. Yes, and this is the way you do that. You want to change these inequalities into equations. Yes, and the way you do that is by adding something called the slack variable. So for example, for this first one, you get 2x1 minus x2 plus 3x3, and then you add a slack variable s1, and then you will have equality equals 6. Because if this is less than or equal to 6, then you can add something to it to make them equal. Yes, and the thing that I'm adding is a variable called s1. It's called a slack variable. And I do the same thing for the next one. So I get x1 plus 2x2 plus 4x3 plus some s2 may make that equal to 8. So again, the same idea. If this quantity here, if this linear combination of x1, x2, and x3, if this is less than 8, less than or equal to 8, I can add something to the left side to make them equal. And that thing I'm adding, I call it S2. It's called the slack variable. Are we good so far? Now, what do we do with the objective function? So again, this is called objective function. This is what you're trying to maximize. So sometimes we use F, sometimes we use P, doesn't matter. F is what we're trying to maximize, find the maximum possible value for. So what do we do with that one? We bring all these terms on the right, we bring them to the left. And what do we get? We get minus 3x1 minus 5x2 minus 2x3 plus f is equal 0. So we need to do these things to the inequalities and to the objective function, and then we will have something that is very familiar for you. Yes, we have a linear system, and we can write down the augmented matrix for that linear system.
So could you repeat the last thing you did, please, with the last line, how you got the minus 3x1?
Yeah, I just moved all these terms from the right to the left. So just move it to the other side, move this one to the other side, move this one to the other side, so that you are left with 0 on the right side. Is that clear?
Yes, thank you.
Sure. And now you have a linear system, and this linear system, it has 6 variables. x1, x2, x3, these are variables. s1, s2, and f are also variables. So when you want to write down the augmented matrix, you need a column for x1, you need a column for x2, a column for x3, one for s1, one for s2, and you will need one column for f. And then you will have a column for the constants. We're going to call that the right-hand side column for the constants, the 68 and the 0. So if I look at the coefficients of x1, I get 2, -1, then 3 for this, 1, 0, 0, 6. Then the second row would be 1, 2, 4, 0, 1, 0, 8. And the last row, -3, -5, -2, 0, 0, 1, 0. And then I can just put a dashed line here that separates the objective function from the equations, and also a dashed line here that separates the coefficients from the constants on the right-hand side. So this is called the Simplex Tableau. And you can just compare what I did over there with what we have here. So this step here that I did is missing, but this is something that you can do mentally. Yes. So here we have 1, 2, 3 equations. And if we have 3 equations, we need 3 slack variables, S1 for the first equation, S2 for the second equation, S3 for the third equation. So we're going to get 1, 3, 1, then 1 for S1, 0, 0, 0, 9, 0 for S2, 0 for S3, 0 for P, and 9. For the second equation, we get 1, 6, negative 1, 0 for S1, 1 for S2, 0 for S3, 0 for P, and then 2. For the third one, 0 for X1, 2, 1, and then we have 0 and 0 for S1 and S2, 1 for S3, 0 for P, and then 5. And then if I move everything here on the right to the left, I will have negative 6, negative 2, negative 8, 0, 0, 0 for the 3 slack variables, S1, S2, S3, and then 1 for P. And on the right side, I will have 0, just like the one that I just did on the right.
Sir,
Yes?
is the reason we don't write S3 because the F acts as the third slack variable?
There is no S3 in the one that I showed you because there are only two equations, two inequalities. Yes. So this one here on the right from the test, there are 3 equations, 3 inequalities. Yes, there are 3 inequalities. So you need S1 to make the first one an equality. You need S2 to make the second one an equality, and then you need S3. So for this one, you need 3 slack variables. That's why here you have 3 columns here. Yes. So you can actually, I can put a dashed line here to separate my slack variable from the other variables. Yes. So I needed 2 slack variables because I had only 1, 2 inequalities. But here there is need for 3 slack variables because there are 3 inequalities.
Okay, thank you.
Okay, good. Any other questions? How you write the tableau? Okay, when you write the tableau, after that, what you need is an algorithm. The algorithm is similar to the Gauss-Jordan elimination, but it is not exactly that. Actually, for example, you're not allowed to swap rows. So that row operation you cannot use. Also, when you want to create, okay, let me just do the example for you. And I will show you what things you can do and what things you cannot do. Some terminology that you need to use. We have something called the basic variables and the non-basic variables. So here I explained how to construct the tableau, and then what is a basic variable and what is not a basic variable. So when you look at this tableau, there are some columns that are unit columns. Yes, like this one here, S1, you have 1, 0, 0. There is only 1, and the rest of the elements in that column are zeros. The same is true for S2, the same is true for F. So at the moment, in this tableau, you have 3 basic variables. These are called basic variables. And then all the other variables are called non-basic variables. So in this initial tableau, X1, X2, and X3 are non-basic variables, and S1, S2, and F are basic variables. So here you have the definition. Basic variable is a variable if it corresponds to the column in the tableau that has exactly 1 non-zero element, usually 1, i.e. variable which corresponds to the unit column vector of the tableau. The other variables are non-basic. So in this initial one, we have S1, S2, and F that are basic. What we're going to do is that we're going to, the number of basic variables always stays the same. And what we're going to do is that S1, S2, and F should become non-basic variables, and X1, X2, X3 should become basic variables, or maybe just X1, X2, and F will become basic variables. So the kind of operations that we do is towards that goal. Okay. Now, the last row of the tableau is called the objective row because it comes from the objective function. What you need to do is, in each step, we need to find a pivot. We need to find a pivot position. How do we do that? We look at these numbers here in the last row, the objective row, the negative numbers. Yes. And among these numbers, we find the smallest one. So -3, -5, -1. -5 is the smallest one, right? Or we can say it's actually the biggest one in terms of absolute value. If I take the absolute value, I will find that the absolute value of -5 is bigger than the absolute value of -3 or -2. We will be done until all these numbers here are positive or 0. Yes, now we have 3 negative numbers, and among those 3 negative numbers, we find the smallest one. In this case, -5. So our pivot position would be in this column, in the second column. And then among these two positions that can be pivot positions, and we should turn them to 1, we just look at the ones that are positive. In this case, there is only 2 that is positive. If there are 2 that are positive, we would have to do this. We would have to divide the number on the right-hand side by the number that we have over here for each one of these numbers and find the smallest one. Yes. So just imagine that here you had a 1 rather than a -1. If you had a 1 rather than a -1, then you had 2 candidates for the pivot position. Yes. Then you would say, okay, I'm going to divide 6 by 1. I get 6. I divide 8 by 2. I get 4. Okay, so 4 is less than 6. So this is my pivot position. In this case, this cannot be a pivot position because it's a negative number. You only look at the positive ones. Is it clear, or do you want me to explain that again?
Can you explain it again, please?
Yeah, so you're supposed to find a pivot position and then turn that into a 1. Yes, how do you find your pivot position? It's like this. So in the objective row, the last row, here you have some negative numbers. Yes, sometimes you have 2 negative numbers, sometimes you have 3 negative numbers. So sometimes one of these could be positive. The one that's positive, you just ignore that. You look at the ones that are negative. In this case, I have 3 negative numbers. You pick the smallest one. In this case, -5. So that's how I determine that this is my pivot column. Okay. Now, between -1 and 2, I have only one choice because the pivot position must be positive. So if I have a negative number again here, I will ignore it. I have a negative number here, -1, so I will just ignore it. That leaves me with only one choice. 2 is the pivot position. I just want to tell you what happens if you have 2 or 3 candidates. So imagine this was a 1. If this was a 1, you need to do this. You divide the number on the right-hand side by the corresponding number in your pivot column. So imagine this is a 1. 6 divided by 1, 6. 8 divided by 2, 4. You pick the one that gives you the smallest quotient. 4 is smaller than 6, so I would pick this one, even if this was a positive one. But in this case, there is no testing like that because we only have one candidate, one positive number here. Make sense?
Yeah.
Okay, good. So what do you do next? You're gonna divide this row. You're gonna divide this row by 2 to get a 1 here. So in your pivot position, you need to get a 1. So if you do that, you're going to get 1 over 2, 1, 2, and then 0 divided by 2, 0, 1 divided by 2, 1 over 2, 0, and then 8 divided by 2, 4. So you get this. Make sense? So you find your pivot position and you introduce a 1 by dividing that row by the right number. In this case, I have a 2 here. To get a 1, I need to divide by 2. Your next step would be to introduce zeros above and below that leading 1. So for that, I will have to do row 2 added to row 1. That would be the new row 1. And I would have to do 5 times row 2 added to row 3. So 5 times row 2 added to row 3. That would be the new row 3. Make sense?
Yeah.
Okay. So I do that, I get this tableau. Okay. Now I'm going to erase this. Then I have to repeat the algorithm. Why? Because I still have a negative number here. You see, I began with 3 negative numbers. But after doing this first set of row operations, I am at a position where I have only 1 negative number here in the objective row. So my next pivot position would be in this column. And when I look at this column here, I have 2 candidates for the pivot position. I have 5 over 2, which could be in the pivot position, and I have 1 over 2, which could be in the pivot position. So I need to pick between these two. What do? I'm going to divide 10 by 5 over 2 and divide 4 by 1 over 2 and compare. The one that gives me a smaller quotient is the pivot position. So if I divide 10 by 5 over 2, I'm going to get 20 over 5. That's 4. But if I divide 4 by 1 over 2, that's going to be 8 over 1. That's going to be 8. 4 is a smaller. That means my pivot position is going to be here in this oval. So you see, it's the same algorithm. I did the same thing to get this pivot position. But don't forget, if you have a negative number, that's automatically out. Yes, you only do this test, the test that I did over here. You only do it for the positive ones. For this column, I had 2 positive ones, so I have 2 candidates for the pivot position. So I checked 10 divided by this number, 4 divided by this number, which one gives me a smaller quotient? That's the pivot position. So what do? I have to introduce a 1 there. How can I introduce a 1 there? I will have to multiply this first row by 2 over 5, because 2 over 5 times 5 over 2 would be 1. Make sense?
Yeah.
So since one step has been skipped, I'm going to do that step for you. So if I multiply that by 5 over 2, I get 1, 0, and then 2 over 5 times 5 is 2. 2 over 5 times 1 is 2 over 5. 2 over 5 times 1 over 2 is 1 over 5. 2 over 5 times 1 over 2, yes, 1 over 5. Then I get 0, and then 2 over 5 times 10 is 20 over 5. That's 4. And then I have the 2 other rows, 1 over 2, 0, 2, 0, 1 over 2, 0, 4. And then I have the last row, negative 1 over 2, 0, 8, 0, 5 over 2, 120. No change there. Yes. So this step has been skipped. It's only getting a 1 in this position by multiplying this row here by 2 over 5. So you get 1, 0, 2, 2 over 5, 1 over 5, 0, 4. Now, what is the next step? To introduce zeros here and here. And for that, you need to do row 2 minus half of row 1, and you need to do row 3 plus half of row 1. And if you do these operations, you're going to get this. Make sense? Any questions so far? Okay. Now, when I look at my objective, row, I see there is no negative number left anymore. And if there is no negative number left anymore, that means I'm done. And from this tableau, I can write the answer. Yes. So now I look at my basic variables. I can see that x1 is a basic variable now because there is a unit vector for the column corresponding to x1. x2 is also a basic variable. x3 is not a basic variable. And f is also a basic variable. So I can easily write the answers now. x1 is equal 4. x2, which is my basic variable, the second basic variable, is going to be equal 2. And f is going to be equal 22. That's the maximum value that can be achieved when x1, x2 are these values. What about x3? x3, which is a non-basic variable, is supposed to be 0. So this is the answer to the simplex problem. That is, the maximum value for f would be 22, and that maximum value would be attained if x1 is 4, x2 is 2, and x3 is 0. Are we good? The non-basic variables, you make them equal 0. Like in this case, x3 is non-basic, so it's 0. The basic ones, the ones where you have a unit column, like x1, x2, and f, those are the variables that you can read the values for from the last tableau. Yes, so f is 22, x1 is 4, x2 is 2, and x3, which is non-basic, is going to be 0. So when do you know when exactly you have to stop? You stop when you have no negative numbers here. If you have no negative numbers here, you know that you can stop and you can read the answer. Are we good? Okay, let's look at this other example. Example 2. So I have 1, 2, 3. First of all, it is in the standard form because you want to maximize. The inequalities, all of them have the form less than or equal to. The numbers 5, 4, and 17, all of them are positive. And x1, x2, x3, all of them are greater or equal to 0. So that's the standard form for a simplex problem. We can use this method for that. We have 1, 2, 3 inequalities. That means we need 3 slack variables, s1, s2, and s3. So we create equations. The first equation plus s1 equals 5, second one plus s2 equals 4, third one plus s3 equals 17. Then for the objective function, we move everything to the left. So we will have negative 4x1 plus 3x2 minus 2x3 plus p equals 0. Are we good? Now we can write the simplex tableau. Very easy. Just write down the augmented matrix. You need 1 column for x1, 1 column for x2, 1 column for x3, 1 column for s1, s2, s3, 1 column for p, and you need 1 column for the right-hand side, the 5, the 4, the 17, and the 0. Then you need to pick your first pivot position. Yes, so you look at this last row. This column is out because you already have a positive value here. 3 is positive. So this column is out. You have -4 and -2. Which one is smaller, -4 or -2? -4 is smaller. Okay, so that means I know that my pivot position will be in this column. It's either this position, or this position. Now, how do I pick between these three? I have to divide the number on the right hand side by the corresponding number. For the first position, I get 5/1. For the second one, I get 4/1. For the third one, I get 17/2. 17/2. This is just 5, this is just 4, and this is 8.5. Which one is the smallest? 4. That means this is my pivot position. And fortunately, I already have a 1 there. If I didn't have a 1, I would have to divide by whatever number I had here to get a 1. But in this case, I just have a 1. So my next step would be to introduce zeros above and below that 1. So I need to do R1 minus R2 to get a 0 here, R3 minus 2R2 to get a 0 here, and R4 plus 4R2 to get a 0 here. And of course, I do these things for all the rows, for all the columns, and I will get this. Is it clear? Now, I look at the bottom, I see I have 2 negative numbers now. Yes, I have 2 negative numbers. And between these 2 negative numbers, -2 is smaller than -1. So my next pivot position is going to be in this column. And among the positive numbers that I have here, I have 1 and I have 3. 0 is automatically out. Why is it out? Because I only look at the positive numbers. If I have a 0 or a negative number, I ignore it. So between 1 and 3, if I divide 1 by 1, I get 1. If I divide 9 by 3, I get 3. So 1/1 is 1. 9/3 is 3. This is a smaller. So that's my next pivot position. And again, I'm lucky. I have a 1. If I don't have a 1, no problem. I just divide this row by the right number to get a 1 here. But in this case, I already have a 1. I need to introduce zeros here and here. So I will have to do row 3 minus 3 row 1 and row 4 plus 2 row 1 to introduce zeros. And I'm not done yet after doing that because I still have a negative number here. I will be done when all these numbers here are non-negative. So at this point, I know that I need to do another set of row operations. So my third pivot position will be in this column. And here I only have one choice because this is 0, cannot be pivot position. This is negative, cannot be the pivot position. It's definitely this position. I need to introduce a 1 there, so I divide this row by 3. I get this. And then at this point, in order to introduce zeros above and below, I need to do a row 2 plus row 3 and row 4 plus row 3. This will give me the last tableau. And from the last tableau, since there is no negative number here, I know it's the last tableau and I am done. I can read the answer. X1, X2, and X3, all of them are basic variables along with P. X1 must be 6. X2 must be 2. X3 must be 1. And these x's will give me the maximum value for p, and that maximum value would be 20.